Good morning, class. Well, today a little bit slow. Still got a few, okay, haven't joined the class yet, including Song Jian. So, any question related to previous lecture? While waiting for them. Yeah, good morning, Adin. Now, after today's lecture, okay, I consider I have done the lecture on active filter. Then Monday, okay, next Monday, yeah, next Monday only lecture. There's no lab. We will try to sort of get our tutorial done. So the tutorial here may take 2 hours. All right, then after finish the this tutorial here, right? I think you all can start to prepare your this lab practical. So I will spend a little bit of time tell you what I want for the practical. All right, so follow schedule, okay, we are going to have our lab practical on week 8. All right, but I'm doing very fast. Not because I'm doing very fast, okay. It's because, okay, sometimes, okay, the lab is, sorry, the tutorial is faster lah, because you are good, okay, do your homework. So now up to you all. If you all want the lab to be scheduled earlier on week 7, we can proceed, okay, because once I finish my this tutorial on active filter here, you should be able to know what to do in the lab. But I leave it to you all lah. Okay, or maybe later, okay, if I finish this part already, okay, I can come up with a pool, okay, let you all decide, okay, would you all want to start your lab earlier? But to start the lab, okay, you need to do, of course, okay, some design first, okay, some background work first, before you sort of, okay, start trying to look for those info required for the lab. The due date we can discuss, no problems. Currently, are you all having a lot of assignment? How many? One subject, 3 assignment. Wow, where got so many one? One subject, normally the most is 2, okay? What subject is that? The lecturer must be very hardworking. Project management, oh, Dr. Xiu, and I think Dr. Xiu and this Miss Lim Juing, okay, they run, okay, this subject concurrently, isn't it? Therefore, let's say Dr. Xiu give one, Miss Lim Juing give another one, then yeah lor. Miss Lim Juing, yeah. So no problem, we can start the lab first, okay, then the the date of submissions, okay, we can make it a little bit later, not to say too late lah, okay, maintain as usual, no problems. So later on then only I come up with a pool. 1, 2, 3, 4, 5, 6, 7, 8, now got 11, one more to come, one more to join. Who is the one more? Who is the one more? Yin Xian, is it? Yeah, Yin Xian. I say this is the guy that I must pay more attention. Yin Xian, okay. Can someone just no, WhatsApp him? Okay, waiting for him, then we will start our lecture. Now today's lecture not too long, so I think less than 1 hour we can get it done. Okay. Meanwhile, any questions? Gibbon, start doing your this revision. Now, we also going to have a test cover until active filter. That will say 3 topics lah. FET, differential amplifier, up to active filter. So you're going to see at least 3 questions on your test here, cover these 3 topics. That one follow schedule, okay, that you see in the form B. The test is on, is on week 8. So the test, okay, definitely we are going to do it on Monday because of Wen Yang. Wen Yang only joined us on Monday. I'm not going to prepare another test paper for him. So test is on Monday, week 8. You got vaccine on week 8 Monday. What time? Ren Jian? 12:30. Is it very far away, okay, the vaccine center, okay, from your house? 30 minutes. That is to say you need to go at 12. No problem. We start at 10. Yeah, finish the test, okay, then you go. Any other students, okay? Come late a bit, never mind. Yeah, if you go to vaccine center a bit late, okay, they won't question you one. Okay, because there are other people coming early. So majority of you all got vaccinated. Our Yang still haven't joined. Majority of you all vaccinated. Second dose next week. Wow, I think you're very fast, faster than me, okay, old fella. So I think grab the first time is it? Today first dose Yin Xian first dose today. First batch AZ. I grabbed the second batch one. Okay so I think most probably okay will be able to see your next year January semester. At least okay we still got one subject, okay. I still have one subject you're in the second year 2 sem 2. Then no more, you go to 3rd year already. Okay, Yang Xian still don't want to join, so not going to wait for him. Otherwise, okay, I need to rush later. Okay, so if there's no particular question, then I am going to sort of start my lecture here. Okay, let me share the screen. Share. Okay, now last week here, we've seen one model of our active filter, which is based on Salem key model. Actually, more simple than this. You're going to find that, okay, in Salem key model, basically, I have only 4 components. Okay, 4 components. Out of these 4 components here, you can have 2 capacitor. Actually, you must have 2 capacitor and 2 resistor. All right, and this Salem key model here can form your high pass filter as well as your low pass filter. So you need to know the transfer functions of your low and high pass filter in order to decide, okay, which are the components here, whether it's a capacitor or resistors, things like that. Okay, now today here, we are going to look at another model here, which is called infinite gain multiple feedback filter circuit. Why infinite gain? Okay, multiple feedback. So multiple feedback is here. So you are going to find that, okay, there are 2 feedback elements, all right, from your VO, bring back to your input here. Infinite gain here is because, okay, you find that these op amps here, look at this op amp here, okay, it is not the same as the previous one here. All right, this previous one here, you have, okay, components that link the VO to the inverting terminal. All right, so for this infinite gain multiple feedback filter circuit here, the positive or non-inverting terminal here is shorted to ground. All right. With this one here, you are going to get something so-called your infinite gain here lah. All right. So this part here, multiple feedback. Now, remember, okay, when we study the OM that time, if we see this type of connections here, okay, these connections here, basically, okay, we are actually now doing something called inverting amplifier. Inverting amplifier. So the inverting amplifier here will sort of let us know that, okay, the gain, or sorry, the output that we are going to see here, okay, will be out of phase compared to the input. So if I will do the transfer function, not necessarily there's a gain, so I call it as transfer function. You are going to get that, okay, this transfer function here is a negative value because the amplifier that you are dealing with here is inverting amplifier. All right, and this same inverting amplifier circuit here, we also learned that, okay, it would be used, okay, to describe the concept so-called virtual ground. Okay, virtual ground. So with this, okay, you are going to find that these points here, the VB point, okay, these points here is your virtual ground. Okay, virtual ground. So this virtual ground here indicates to me that it's a 0 volt. So this value is the same. So you are going to find that your V negative having the same value as your V positive, which in this case here is a 0 volt. All right. So normally when you write, after writing these equations here, you got to tell that this is a virtual, okay, virtual ground. All right, virtual ground. And these things here only happens for ideal OM, whereby their open loop gain here is infinite. All right. So now for this multiple infinite gain multiple feedback here, you are going to find that 1, 2, 3, 4, 5. There are 5 elements here. So out of these 5 elements here, earlier is a very straightforward, okay, 2C, 2R. So this one here, maybe I'm going to have 2C, 3R, or 2R, 3C, things like that. So we need to work out, okay, what are the components, okay, what type of component am I supposed to put for this put into this circuit here so that they form the type of filter that we need. Okay, so same thing here. The Y, okay, here represent admittance, admittance. So my this derivations here will be depends on TT, okay, will be depends on, okay, based on admittance derivation. All right, because last time prepare these things that time to get it as impedance is very difficult. You have to divide the equations, okay, use is not so user friendly yet. So convert everything into admittance. Okay, so with this one here, let's say if I want to start doing my derivation, of course, okay, I will start off with something that is easier here. So I will start at these nodes. Okay, this node. So I mentioned here at node. Okay, at node. Okay, B, always, okay, indicate clearly, okay, which is the point that you are dealing with. So for this point here, because you know that this is virtual ground, which later on I'm going to put it in here, therefore I will choose that, okay, current to flow this way. All right, go into the point B. And this point here is labeled as VA. Okay, VA. Okay, so we have a VA minus VB, and because we talk about admittance, so we times it with Y3. All right, so another current coming in here is from VO go to VB. So VO potential difference is a VO minus VB times with Y5. Okay, only 2 current flowing, so therefore this is equals to 0. So I'm trying to sort of simplify these expressions here. I'm going to tell you here VB is equals to 0 volt. Why this is 0 volt? Because this is the virtual ground. Okay, so virtual ground. So I sub, okay, I can put it here, make it faster. I sub VB equals to 0, which is a virtual ground, into equation. Okay, into equation. Okay, then you are going to find that this equation here become very simple only. Wk5. All right, and in this sort of circuits here, VO, we measure the output. V in, we supplies the input. A and B, okay, is a label that we add in, okay, for us to do our derivation. So therefore, in this case here, VA later on, okay, I need to substitute. Okay, I want to get rid of the VA in my final expressions. So therefore, VA in this case here, I bring this one over. So this one here become negative VO Y5 divided by y3. And this one here, maybe I can call it as equation. If I follows the notes, they call it as an equation. Let me just double check. They call it as a equation 3. Okay, so I just follow lah for you to refer. Okay, so this is one of the equation. Later on, I need to substitute, and of course, okay, VB is the another equations that we are interested in. So this VB equation in the notes here is called as equation number 2. This one here is the equation number 1. All right, so I have done everything on my this point B here. So next, I am going to continue at point A. So we always do the easy one first, okay? Because from there, okay, later on, if I want to do substitution, okay, it will be faster and easier. Okay, point A here. Now, of course, suka hati you want all current go in, some current go out, okay? Or all current go out, suka hati. Eventually, okay, answer should be the same if you do it correctly. So I follow the notes here. They are doing, okay, current all go out. Reason why all go out here is because this one go to ground, okay? So you're going to find that maybe this expressions here is easier. All right, this one also virtual ground. So there are two here are very easy, okay, that you can get your expression, make it more simple. Okay, so in this case here, I start with this point here, VA minus my VI. I times it with the expressions of admittance Y1. Okay, then plus it with VA follow in clockwise direction. Okay, VA minus VO. Again here is times with my Y4. This one, okay, this one here, write it in full first. VA minus VB times with Y3. Okay, then one more. Okay, is the VA times it with Y2. This is because, okay, obvious that this is the ground. So I just do it as in this way, okay? So rearrange this equations here a bit and substitute, okay, my VB here with 0, the virtual ground, okay? Rearrange and sub equation 2 into this one here. I am going to label it as 4. All right. So you are going to find that, okay, these expressions now, I try to gather. Rearrange means that in this case here, I try to gather all my VA together. Okay. So you are going to find that VA, because later on I want to substitute directly. Okay. Just substitute one time only instead of many times. Okay. In this case here, 4 times. All right. So we gather the VA together, group them together, and you find that now you have your Y1 plus. So if I go accordingly, this one here, Y2 first, then my Y3, because they are all in the same directions, I take all current going out. So definitely all will be plus. Okay, so I group the VA first. Then next, okay, this part here, because it's negative, okay. Now up to you, okay, whether you want to leave it on this left hand side or you want to bring it to the right hand side, because okay, bring it to the right hand side here, you are going to find that the negative disappear lah. So suka hati ya. So in this case here, let's say okay, I bring it to this right hand side. Okay, and this one here become my plus VO Y4. This one here, remember we say we substitute these equations here, then no more. This one here also, there's nothing here. So I have these expressions. Okay, so with these expressions here, I am now going to substitute my VA into it. Sub VA from equation 3 into well, okay lah, just put it as into here lah. So you're going to find that okay, my these equations here, I need to copy this one first before I move out. Okay, y3. Okay, so this is the one. Then this whole thing here should times it with y1 plus y2 plus y3 plus y4. Okay, so this is a expression that I am going to have. Okay, so now with these expressions here, I will sort of rearrange it something, make it something like this one. Okay, I try to find the transfer function. Always, okay, your aim here is try to find the transfer function. So with that, okay, you're going to find that I have a VO here. I also have a VO here. All right. And we know that we are using op amp, which is inverting amplifier. So with this, okay, this VO, the negative is here lah. Or all right. So before I sort of okay sum them together here, I want to shift my Y3 to this side. Okay, make it linear, everything linear. So you find that okay, I will have this one. Okay, so this one shift up here. So it's a VI, Y1, Y3 plus VO, Y4, Y3, Y4. Okay, so try to group the VO together. Okay, VO and VO together. So because this is linear, all right, so I'm going to shift this one to this side become negative. So I have here is sorry. So VO minus VO minus VO Y5. Okay, Y5. I'm a bit lazy, okay, to write this. Okay, minus the VO Y3 Y4 equals to VI Y1 Y3. Okay, once this thing is done, then you take out the common VO. Common VO. Okay, the common VO I take out, then you are going to find that these expressions, okay, this expression become negative Y5, or I leave the negative outside here. After all, I need this negative later. All right. Okay, Y5 times with the, okay lah. Y4. Okay, so I finish this part. So this negative VO also bring to the outside. All right. Then what is left behind here become positive Y3, Y4. Okay, so VI, Y1, Y3. All right, so I can see my answer already. So you are going to find that, okay, we take VO over VI. Then this whole thing here, I'm going to shift it. Okay, shift it to the right hand side. Of course, with this negative here, if you, okay, don't want to retain your this negative on this side, so this negative will appear here as negative Y1, Y3. And follow exactly. So I write this one here first. Okay, plus with my Y5, 1, 2, 3, and my 4. So this is the expressions that we obtain for the infinite game multiple feedback, okay, model, okay. So based on this equation here, now we have to make some decisions. The decision is, okay, should my y1, y3 up, sorry, y1 up to y5 here, which one is a resistor, which one is capacitor? Now, to achieve this, okay, you cannot just write this from here. So you have to make some decision. So first, I want it to be low pass, to form low pass, okay, low pass filter. So I must know, okay, the transfer functions of low pass filter. So which the transfer function is given as, remember, I asked you all to sort of, okay, memorize this expression. So you're going to find that this one here is some constant. Okay, other books may use different label. It is okay, but the denominator here is a fixed. So you have a s squared plus your omega. Now, some books, they put a not here. Others, okay, may not be putting. So in my case here, I put it. So I just follow. All right. So over the Q is the quality factor times your x plus omega naught square. Okay, so this omega here actually is the angular frequency at a cutoff. Okay, so it's the cutoff angular frequency. So to form this low pass filter, okay, to form this low pass filter, I must make this equation. Okay, try to arrange this equation here similar to this. The negative, no problem, okay, just take it as a constant, and the gain here, okay, is out of phase, that's all. Okay, so you can no need to bother about the negative. So what we need to see here now is this is a constant. A constant. Constant in the sense that there's no S. Okay, here, no S. This S. Okay, the J omega. Okay, so therefore from here, very obvious, okay, I can tell you my numerator here. This numerator here shouldn't contain any capacitor. Okay, because this one got no S. So this numerator, which is formed by Y1 and Y3, okay, must be a resistor. No J omega, it must be resistor. So I managed to get my Y1 and Y3 already. Then next, I try to work out, okay, other components. I must make sure, okay, my denominator can fulfill this requirement. Okay, so by looking at this, okay, I already decided that, okay, this part here, okay, this one here is a resistor, so 1 over R. All right, so this is 1, so 1 over R. This is 1 over R. So first thing now is I try to get my S squared. Now, in order for me to get S squared, my Wk5 somehow must be a capacitor, because it times with any of this here, it must be a capacitor. All right, it must be a capacitor to form one of the S here. Okay, one of the S here. Then another capacitor can come from Y2 or Y4. All right, I repeat, another capacitor can come from Y2 or Y4. But then here we look at this one. If this is a capacitor, this is a capacitor, then you have a S here also. Okay, so in that case, okay, Y2 got to be a R, and you make the circuits here more complex. So therefore, in this case, this one here, if we choose this one as a resistor R, this one resistor R, then left behind this one here, I am going to get capacitor for Y2. So with this, okay, these two times up, I'm going to get my S squared. All right, these two I times up. Okay, these two I times up. I'm going to get my omega square. Now, if this one I put SC, then I may not be able to achieve my omega square. Omega square again is something, okay, without S, no S. All right, so therefore Y4 must be a resistor. So that Y3 and Y4 you times up to form your omega square. Then next, inside here, this one times with your Y1 as well as your Y3, Y4. It is going to form your factor of your S, omega naught over your Q. Just to recall, quality factor, not Q point, quality factor. Remember yesterday I say your bandwidth here depends on your F over the Q. Okay, F is the peak value. Okay, peak value. So sometimes your books they call it F, F not simply any F, but it's the peak value of the bandpass filter or the frequency response curve. All right. So conclusion now is to form a low pass filter, I am going to choose Y1, Y3. Beside Y1, Y3, one more Y4 as resistor and Y2, Y5. I'm going to choose capacitor for it. Okay, any questions on this part? Hold on, okay, we'll answer later. Okay, then now second, I want to form high pass. Okay, to form high pass filter, I need to know the equation, which in this case here, you are going to find that so we just don't want to conflict with the same A. So therefore, I can call this one here as A2. Okay, S square, J omega. Denominator remain unchanged. Okay, so this is my high pass transfer function. So based on this high pass transfer function here, now I analyze this equation. How to form this? First thing, very obvious, my Y1 and Y3. Okay, Y1 and Y3, I must use capacitor. Okay, so 1 over SC1, another one, this is admittance. So SC1 times with SC2, you are going to get your S squared over here. Okay, so very obvious, these two must be capacitor. Then next, I need to form my S square. So I know now this is a capacitor SC, Y1. This is the capacitor. I just take all are SC, so this is also your SC here. So now, how to get my maybe omega square. Remember, omega square here, there's no S. So that is to say that my 5 cannot be SC anymore. All right. So because if you were to times it with all this inside, somehow you will not be able to get these terms here. So this one must be a R. Okay. So if this is a R here, then Y2 and Y4, any one of them is a R here, I will be able to get my omega square. Okay, so we decided for Y5 already. Next, I may want to consider the S square at the denominator here. So since this is Y5 already, now if this one I put a capacitor, I also don't get my S square. So if my Y4 I put a capacitor, I won't be getting the S square from here, but I can get S square from this combination, Y3, Y4. So therefore, I managed to get my S square if Y4 is being okay, a capacitor. All right. So this one here, now Y4 is a capacitor. Then what about Y2? Okay, what about Y2? So do I need a capacitor for this? So usually the answer here is we will choose the easiest one, 1 over R. Okay, so resistor. Okay, we are going to use resistor for this part. So as a conclusion, you are going to find that, okay, now I have Y1, Y3 as a capacitor. On top of that, okay, my Y4 also a capacitor to form the S square over here. Then, of course, a remainder now, the Y2 and Y2 and your Y5 will forms by resistor. And I need this Y2, okay, times up with Y5 to give me the omega square. Okay, so this is the only terms you times up without S. Okay, so this is the conclusion if I want to have high pass filter. Okay, next. Which, okay, the salient key, okay, cannot achieve one is the band pass. Third, okay, I want to form band pass. Okay, band pass filter. So for the case of band pass filter, you are going to find that their denominator also the same. So it's a S square plus omega over QS plus omega square. So if they want to have a knot, I give them a knot. All right. So this denominator here is good for all second order. Okay. So for all second order filter, their denominator is the same. What is changing here is only the numerator. Okay, so for band pass filter here, you are going to see a single S appear here with, okay, a constant. We label it as A1. All right, now we analyze the equations again, and we sort of, okay, wanted to meet this requirement. So let me. So in these expressions here, first thing very obvious is that my Y1 and Y3, okay, Y1 cannot be the same as Y3 because only one of them going to be a capacitor, the other one is a resistor. All right, so first expressions are. Then we try to look at the denominator over here. I want to meet this requirement. Okay, I want to meet this requirement. So we are going to find that, okay, how to get my omega square. Okay, maybe from Y3, Y4. Okay, maybe from Y3, Y4. Or maybe from this Y5. Okay, I make sure that this is resistors. Then inside here, another component here, which is a resistor as well. Then I can achieve my omega square. Okay, so based on this equation here, maybe something that is very straightforward is that if both of these Y3 and Y4 I use SC capacitor. Okay, capacitor. Then I meet the requirement for my S square. All right. So if 3 and 4 are SC, then you know that Y5 cannot be a S. It must be a resistor. And next, okay, if Y3 is a capacitor, Y1, which we say that cannot be the same type, okay, as this Y3, it then must be a resistor as well. Okay, now question now is Y2. Okay, Y2. So you are going to find that, okay, well, design purpose, okay, we try to have, okay, more simple design. So in this case here, we try to eliminate, okay, if we no need to have the S, okay, so we are not going to use this one as, we are not going to use, okay, capacitor to be placed in my Y2 here. So this one here, we are going to use it, resistor. So I can have my omega square from here. I can have my S from combinations of these two. Very complex already, but no choice. Okay. From here, I have my S square from here. So conclusion from this this concept here, we are going to find that, okay, my Y3, Y4. I'm going to use capacitor. Then 1, 2, and my 5 here, I'm going to use resistor R. Okay, so this is where you see it in this okay, these these parts here. All right. Okay, so since this one here is a band pass filter, so you are going to find that, okay, band pass filter, their response curve very similar to what we have studied for flat, okay, frequency response of flat. Okay, so this is where I'm going to get my omega naught or F naught, depends on your list axis here, whether it's omega or frequency. Okay, so the center frequency. Okay, center frequency. All right, and the gain for this band pass filter, gain for this one here is given by your Q over your omega naught. All right, times with the A1. So you need to work out, okay, let's say we have values and so on. I need to work out what is the values of the A1. So I can find the gain for this particular circuit. All right, of course, bandwidth in this case here is this one, FL, this is the FH. Okay, this is omega naught. Whereas in high pass and low pass, okay, low pass in and a high pass. So you are going to find that your omega naught is here. Is the cutoff frequency, okay, or F naught, depending, like I say, okay, depending here, the axis here, whether you are using angular frequency or just the frequency. So the difference between the two, these are two here, two types, low pass and high pass. Omega in this case here is the cutoff frequency. But for band pass, the omega that they refer to, okay, is the peak value. Okay, the peak value is the omega that they are referring to, of the F that they are referring to. So the gain for this band pass here is given by this expression, Q over your omega naught times with the A1 constants, okay, from the expressions. Okay, so generally I cover this one. Then now, of course, okay, here just for the band pass filter, because it's something new compared to the others. So you are going to find that band pass filter, I can achieve this, okay, by inserting, okay, my components. Okay, so this is the 1 over R resistor. All right, resistor. All right, so if we substitute, okay, the okay, the value or the type of components that we derived just now, so I will be able to get expressions as in this form. I substitute only, substitute, then I will be able to get expressions as in this form. So you are going to find that, okay, this whole thing here forms your omega square. Now, see, look at this whole thing here. There's no S, it contains no S. So this is my omega square. Whereas this part here, you see here, S. So this is okay, the factor for the S. Don't memorize this equation, okay? What you need to memorize is this equation, okay? This equation here is after we do substitution, okay? Then we rearrange, okay? Rearrange and we got this. All right. Okay. So my s square, just to remind, always, okay, the factor here is a 1. Cannot be any other value. Okay. Next, these parts. Okay. My A1 is, in this case here, is the same as 1 over C1 R1. Okay. Of course, negative because we are dealing with inverting amplifier. So A1 is given as negative 1 C1 R1. All right. So if I want to find the gain for this particular circuit here, then I apply this A1 here into the A0, same as my Q, which I'm going to get it from here. All right. If I know the value, I can substitute. I can find my Q, and okay, divided by omega naught times with my A1. So since I'm only interested in the gain, whether I am not really going to bother, okay, whether it's in phase of our phase, so you only take the magnitude. All right. So I repeat here again. No need to memorize this equation, but you must know how to obtain these are equations if you are given the types of components. So you need to substitute into the expressions that you obtain, rearrange it so that it has the format of denominator must be s squared plus denominator must be something like this. Then the numerator, depending on you are dealing with band pass, low pass, or high pass. Okay, so in this case here, band pass. Okay, so S. So this one here, if you don't like the A, no problems. You can use anything to represent. Or generally, I just use A to represent also can. All right, so we will be able to work out the omega value, the Q value from the expressions. So more tidy arrangements that for this one here, how I managed to divide this from this equation is by substitutions. All right, then I form the equation that I'm having. So what is being covered here are very ideal. So what I draw here also very ideal. You see, flat, then straight away go down. This one, go up, then flat. This one, very ideal. Band pass, my low pass, my high pass. But if you are dealing with vertical, so you find that instead of get so flat types of response, all right, so you may be getting these types because it depends on the Q that you have in the equations. High Q. This one here, very low Q. All right, so for band pass, you may get this side. Suddenly there is a peak here appear. And this part here, I will not cover because this is something that you are going to learn under your signal processing. They do a lot of filter, different types of filter. All right, so we study here as a flat. All right, high pass, same thing. They will get a peak first, then only they drop. In a lot of these particular filter. So also depends on the type of filter that you are using. Remember in the very beginning, I introduced the type of filter, Chebyshev filter, things like that. So the Q that you are using, you are going to find that this peak value here depends on the Q. This Q here. This one also depends on the Q value. So low pass, high pass, and your band pass can be very sharp. Again, depending on the Q value, or not so sharp, flat a bit. All right, so this is a high Q. This is a lower Q. So low pass, high pass, and band pass. Another one is take this away from here, you terbalik it. So this one forms your notch, or band stop. We call it as notch, filter or band stop filter. Now you are going to see that my lecture here never cover the band stop filter. All right, because the derivations, everything actually is the same. And I only managed to find one questions on this, which is on the, I put it in the tutorial there already. I will explain that tutorial questions. Okay, so my lecture for this part here ends. Okay, any questions? Anyone with any questions? John, got no question. What about the rest? Is Yinshan joining us? Is Yinshan with us? Yes, Yinshan, why so late? Remember I say, okay, every week I have to look for you already. Wi-Fi problems are same reason, same reason. Is it a genuine reason? Is that true, Yinshan? Oh, okay, I trust you. So now if whatever you say, I will try to trust you, okay? Because if you try to cheat, okay, on me, actually I'm not going to lose anything, it's you yourself only, okay? So I trust you. All right. So in this case here, test the time how, exam the time how? Eventually final exam the time, how are you going to solve this problem? Are you using data or what? Yinshan? Wi-Fi, Wi-Fi, who is a provider? Oh, TM, TM, go and buy a LAN cable lah. Remember last time, first time when I have class with y'all, I also got kicked out from classroom very frequent, such that y'all have to listen. Okay, I waited there for 1 hour and I didn't realize. Yeah, I didn't realize that I was not in the classroom. Remember that? So how I solve this problem? I go and buy a LAN cable, a very long LAN cable, okay, 15 meter, but I don't think I need so long lah. I make a mistake, okay. Maybe 5 meter or 10 meters should be good enough. So go and buy a LAN cable, get it from Shopee. Slightly more than 10 ringgit only lah. Okay, slightly more than 10 ringgit, quite cheap. Okay, 2 us away. So then it solve all the problem. Now, luckily, you don't see me. Okay, got kicked out from classroom. Use LAN cable. Okay, so Yinshan also say good. If no LAN cable, I think very frequent you are going to see me. Okay, missing already. From living room to your room, yeah. Last time, okay, I even go upstairs. That's why I buy a 15 meter. Okay, from my living room to my room inside lah. Okay, upstairs. So that's why I buy 15 meter. But now, okay, normally I do my class in the living room. So a bit too long now, but it's okay. So all right, any question related to today's lecture? So I say I'm going to make a pool here, right? Then do you all want to do like I say, okay, because our lecture, okay, do a bit faster, right? So now if you want to sort of, okay, start with your lab earlier. Now next week is week 6, Due date we can discuss later, not an issue. Everybody want to start from week 7 or 8. No, only one vote. Okay, only one vote. Now I don't mind, okay, whether it's week 7 or 8 or 8 or 9. So it's just because, okay, some may say that because usually, okay, towards the end, okay, you got more assignment coming in. So if you can do earlier, then later on you have more time for your assignment. Total now got 9 votes. We should have 12 votes total. Now got 10, 2 more. 9 already miss. 9 plus 1, 10 ma. Majority majority win. Okay, I wanted to find out the reason why, okay, our friend here, week 8 and week 9. Okay, maybe he got this appointment ma. All right. So here got 10 2 more. Not going to work Anything also okay Early start, same or delay submission date equals to ideal. We are not going to delay the submission date. Okay. We just can leave it as maintain submission date. Okay, submission date can be made at the week 9. Okay, I will know who is the one, okay, didn't submit and who is the one, okay, choose the week 8 and 9 because Google will send me a report if I end the pool. All right, but I just want to find out, okay, is it because you got something? Who is this guy here choosing 8 and 9? Okay, who is the one choose 8 and 9? Yinshen why you want to choose 8 and 9? You need to go for vaccine? No, Now, if you are going for vaccine, okay, let me know, So, in that case, okay, we don't care about, okay, majority, things like that already, okay. Now we have to give chance lah. All right. And also reminder, test is on. Oh yeah, just now test is on week 8 Monday. Yeah, just now who is the one who told me that, okay, I need to go for vaccination Just now one guy told me vaccination on week 8. Okay. Okay. Len Jian So now, if Len Jian going to have this vaccination on week 8, then we start our lab will be on week 7 will be just nice. So I will give a little bit of briefing about the report requirement. All right. Then the rest is all on you already. Okay. So we are going to fix it. Okay. Our lab will start at week 7, 7 and 8. So 7 and 8. Or another alternative, it can be 7 and 9. Okay, 7 and 9. Because week 9, basically in this case here is writing a report. If you have some questions to ask, okay, I will be there. Your these simulations will be done. You know, simulations, okay, if you do everything correctly, okay, basically problem is how to analyze the results only. Okay, so should be no issue. So we confirm the lab at 7. We make 7 first, Lab 7.